Scientists at the National Ignition Facility achieved fusion ignition, and that is creating more energy from fusion reactions than the energy used to start the process. It's the first time it has ever been done in a laboratory, anywhere in the world. Simply put, this is one of the most impressive scientific feats of the 21st century.
The sun is fascinating, isn't it? It is the source of light and all life here on Earth. But what powers this huge ball of gas? Stars produce their energy through nuclear fusion. It is the science of producing energy by fusing two atomic particles into one. When you fuse two particles, a part of their masses gets converted into energy. It sounds easy, right? Compress two hydrogen atoms into a single helium atom and reap the benefits of a lot of energy, light, and heat. But how exactly do we harness this energy? This question has plagued scientists for years. But now it seems that we are a step closer to the answer. Scientists at the Lawrence Livermore National Laboratory in California, US, recently announced that they have been able to produce more energy in a fusion reaction than what was used to ignite it.
The researchers took one small, very tiny capsule, like maybe of the size of a grain of rice or maybe even a puffed rice, a capsule of that size. They put some deuterium and tritium in it and hung it and bombarded that capsule with 192 lasers from all around. What happened was with this enormous bombardment of energy on the tritium and deuterium, they exploded. And when something explodes, there is an equivalent and opposite force. So there was also an inward force. This inward force fused some of these nuclei atoms. It's very difficult to bring two protons together because they have a natural tendency to go away from each other. And the closer you bring them, the more energy you need, but up to a certain point. Once you cross that point, some other force in the nucleus called the strong nuclear force takes over, and then it actually, instead of repelling, they come together. That point is called Coulomb barrier. Now you need enormous amount of energy to overcome this Coulomb barrier. Once you overcome this, the strong nuclear forces take over. Scientists say it calls for something like 150 million degrees Celsius, which is something like 6 to 10 times hotter than the core of the Earth. You have to have that much energy to overcome this Coulomb barrier and fuse two nuclei together.
The researchers have announced that they have achieved a net energy gain, that is, to get more energy than it was put in by fusion. The input energy was 2.05 megajoules and the output was 3.15 megajoules.
This net energy gain or excess heat, they are called differently in different experiments. This is the holy grail of nuclear fusion. You have to get more energy out of it than you put in. Only then it makes sense. But there is a caveat here. Here they are only talking about the energy delivered into the capsule. But to make all these 192 lasers work, they had to spend a hell of a lot of more energy.
This is unprecedented, and therefore there's a lot of excitement around it. Why is this such a breakthrough?
This is a breakthrough because scientists have actually seen a net energy gain. That is, they have got more energy than they put in, which establishes that the science works. Now it is a matter of perfecting it, increasing it, and bringing in technological inputs to make it commercial.
Many believe that this is a significant milestone that moves us a step closer to having zero carbon fusion energy that can power our entire society. This experiment might be a success, but the commercial operations of this technology might be a long way off, at least a decade away, experts say. However, some private companies aren't so skeptical.
I can give you two examples here. One is that of a company based in Cambridge, Massachusetts, USA, which is called Commonwealth Fusion Systems. This company has said that it is very close to building a commercial fusion reactor. The timelines that they give is 2025 for a pilot plant and 2030 for a fully commercial plant. Now, should we take this company seriously? There are reasons why you should. One is that this company is backed by very big investors, marquee investors. Bill Gates Foundation, Google, Khosla Ventures, ENI, Soros Funds, a number of them. They all have put in something like $2 billion into this company. So if this company, Commonwealth Fusion Systems, claims are to be believed, which many people do, then probably nuclear fusion is not so far out in the future. This company called Brilloin Energy in Berkeley, California, says it has come up with a device which it calls hydrogen hot tube, and it has actually demonstrated this device in an international conference called ICCF 24 that was held in San Francisco in July, where it actually demonstrated that this machine can produce more heat than it consumes. Now, Brilloin Energy says it is building a commercial reactor that can use the hydrogen in just a glass of water to power 30,000 homes in a year. Brilloin Energy is collaborating with SRI, and Brilloin Energy has claimed that SRI international scientists have independently verified and validated this company's claims. If the claims of these two companies, that is CFS and that is Commonwealth Fusion Systems and Brilloin Energy, are to be believed, there are good reasons to believe them, then it does not appear that fusion energy, nuclear fusion, is so very far out in the future.